Hello, welcome to PH Maths. Number in focus on phi. The Greek letter phi, often called the golden ratio, is roughly 1.618, and it's been called the most beautiful number in mathematics. It's the ratio that every Fibonacci sequence converges towards, the ratio of diagonal to side in every regular pentagon, and the answer to one of the cleanest quadratic equations you'll ever solve. Quick identity check. Phi is positive. Phi is irrational. Like root 5 and root 2, its decimal expansion goes on forever without repeating. Phi is algebraic. Specifically, phi is the positive root of x squared equals x plus 1. And as a decimal, it's approximately 1.61803. The number behind 1,000 pieces of bad design advice and one lovely piece of pure maths. Common multiples of phi, 2 phi, 3 phi, 4 phi. Surds that involve phi are usually left in symbolic form. Like pi and e, phi stays as a symbol until the very last step of any calculation. Don't decimalize mid-working. You'll lose the connection to the Fibonacci sequence, which is half the reason phi is interesting in the first place. Powers of phi. Phi to the 0 is 1. Phi to the 1 is phi. Phi squared equals phi plus 1. That's the defining identity. Phi cubed equals 2 phi plus 1. Phi to the 4th equals 3 phi plus 2. Phi to the 5th equals 5 phi plus 3. Notice the coefficients 1, 1, 2, 3, 5. Those are Fibonacci numbers. Phi's powers literally generate the Fibonacci sequence. Where Fibonacci hides, every power of phi has the form phi to the n equals f minus n times phi plus f minus n minus 1. Each coefficient is a Fibonacci number. Phi squared is 1 phi plus 1. Phi cubed is 2 phi plus 1. Phi to the 4th is 3 phi plus 2. The Fibonacci sequence is hiding inside phi's powers, and the ratio of consecutive Fibonacci numbers, 8 over 5, 13 over 8, 21 over 13, converges to phi. Key relationships. Phi equals 1 plus root 5 all over 2, which is roughly 1.618. Phi squared equals phi plus 1, its defining identity. 1 over phi equals phi minus 1, which is roughly 0.618. The ratio of consecutive Fibonacci numbers approaches phi, and every regular pentagon has a diagonal that's exactly phi times its side length. Where phi shows up in your exam, surd manipulation, simplifying 1 plus root 5 over 2 into phi. Quadratics, x squared minus x minus 1 equals 0 has positive root phi. Pentagon and pentagram geometry questions at higher tier. Fibonacci-style sequences with consecutive ratios converging on phi, and surd rationalization practice. 2 over 1 plus root 5 simplifies to root 5 minus 1 over 2, which is 1 over phi. Where phi hides, every Fibonacci number's growth rate, diagonal to side ratio of every regular pentagon, the fraction root 5 plus 1 over 2, that's phi, and any quadratic of the form x squared equals x plus something is structurally related to phi. Spot the Fibonacci pattern in a sequence and you've spotted phi waiting underneath. Right, if any of this is going to stick beyond this video, drop into phmaths.com. You'll find a free 4-week GCSE Higher revision planner ready to download, plus the mastery workbooks, one for every higher topic, every answer fully worked, every common slip flagged. Simple explanations, serious results. See you next video.